My dear students, now we are going to look at problems and solutions. In that, we are going to look at a 6-bit comparator. So let's say A and B are two numbers. A is A5, A4, A3, A2, A1, A0. B is B5, B4, B3, B2, B1, B0. So what we are trying to do is we need to find that A is less than B, or A greater than B, or A equal to B. Let's say A less than B, A greater than B, A equal to B as say X, Y, Z. Now when X is equals to 1 means A equal to B. Y is equals to 1 means A greater than B. Z is equals to 1 means A less than B. Okay, when X is equals to 1, Y obviously 0, Z obviously 0. When X is 0, either Y may be 1 or Z may be 1. If Y is 1, Z will be 0. If X is equals to 0, Y is also 0, Z should be 1. Because on the whole, any one of the condition will be valid with respect to relative magnitudes of A and B. So what we try to do is, we try to look at it, how to build the circuit. Okay. So if I take this problem, let's say from truth table point of view, what I can do is, say for example, if it is a 2-bit number, I take 0 0. Say if it is a 2-bit number, okay, 2 bits of A, 2 bits of B. So I need to write all possible combinations. 4 bits it will become. Okay. Actually it is 2 bits, but it is 2 bits, totally 4 bits. So 2 power 4 combinations. 0 0, A equal to B is 1. Say X is 1. Y is 0. Z is 0. I need to do all possible combinations 0 0, 0 1, 0 0, 1 0, 0 0, 1 1. Likewise, I need to go up to 1 1 1 1. I need to take all these values. Then I need to get expression for X, Y, and Z. Right? So in general, if I solve like that for a 6-bit number, this is of 6 bits, this is of 6 bits, totally 12 bits. So I need to write 2 power 12 combinations. 2 power 12 combinations is 2 power 10 is 1024, 1024. 2 power 12 will be, okay, 2 power 2 is how much? 4. So 2 power 2 multiplied by 2 power 10. 4 times of 1024. So which will be, okay, we call it as in general 4K. 1024 is known as 1K in digital electronics. Okay, so this is very difficult task. So that's why what we try to do is, we try to look for MSB bits. First what I do is, I don't mind what exactly these values. What I try is, if we will do the comparison process. If A5 is greater than B5, I can say A greater than B. Okay. Or if A5 is less than B5, doesn't matter all these things. Okay. I can say A less than B. If these two are equal, A5 equal to B5, then what we try to do is, we will look for rest of the numbers. Okay. So by doing so, what I can do is, I can get the expressions for A less than B, A greater than B, and A equal to B. So first what we try to do is, what is the condition for A equal to B? Condition for A equal to B is very simple, that if A0 is equal to B0, I can say and A1 is equals to B1, A2 is equal to B2, A3 is equals to B3, A4 is equal to B4, and A5 is equals to B5. Only in that condition it will be equal. I can say A equal to B. So to how to check this A equal to 0, A0 equal to B0? It's very simple. As we know XNOR operation, XNOR truth table, XNOR truth table. Let's say A, B are inputs, Y is output. 0, 0, 0, 1, 1, 0, 1, 1. For 0, 0 output is 1. For 1, 1 output is 0. Sorry, 1. For 1, 0 and 0, 1 it is 0. So this is a circuit which look for equivalence. That means it is equal to 1 when A equal to B. So I will apply that to A0, B0, A1, B1. So what I try to do is, let's call X0 as A0 XNOR with B0. X1 is A1 XNOR with B1. X2 is A2 XNOR with B2. X3 is XNOR with A3 with B3. I am finding equivalence. X4 is A4 XNOR with B4. Next, X5 A5 XNOR with B5. Okay. So X is nothing but, if X0 ANDed with X1, ANDed with X2, ANDed with X3, ANDed with X4, and added with X5. Okay. If all are ones, X becomes 1. X becomes 1 means A equal to B. This is what exactly we are looking for. Okay. So next what we try to do is, we try to look for the other conditions. What is A greater than B? If A5 is greater than B5, I can say that it is A greater than B. So next what I do is, if A5 is equals to B5, then I look for the next. If A4 is greater than B4, doesn't matter. For this, what is not matters? I don't matter rest of the bits. That is A4 to A0, B4 to B0 does not matter. For this case, A3 to A0, B3 to B0 does not matter. When A5 equal to B5 but A4 is greater than B4, I can say that A greater than B still. Or if A5 is equals to B5 and A4 is equals to B4, then I look for, is A3 greater than B3. If that is true, does not matter. A2 to A0 does not matter. B2 to B0, I can say that still A greater than B. So likewise I can say that A5 is equals to B5, A4 is equals to B4, A3 is equals to B3. In that case, I look for the next, is A2 greater than B2. If it is true, A1 to A0, comma B1 to B0 does not matter, I can simply say still it is A greater than B condition is met, A greater than B. Similarly, I can say that if A5 is equals to B5, A4 is equals to B4, A3 is equals to B3, okay, and A2 is equals to B2, then if A1 is greater than B1, does not matter A0 and B0, I can say that still A greater than B. Similarly, A5 is equals to B5, A4 is equals to B4, A3 is equals to B3, A2 is equals to B2, A1 is equals to B1. Then we look for, is A0 greater than B0, still A greater than B. So all these conditions we can write in terms of expression. What is that expression is? A greater than B. The notation that we have used for A greater than B and A less than B, if at all you see, A greater than B is Y. So what I try to do is, I write expression for Y. So Y is 1 when A5 B5 bar or X5 What is x5 means? A5 is equal to B5. Then A4 B4 bar. A4 is 1, B4 is 0. Or x5 x4, then A3 B3 bar. x5 x4 x3, then A2 B2 bar. That means A2 is 1, B2 is 0. Then each is A greater than B. Similarly, x5 x4 x3 x2. Okay. Then x2 A1 B1 bar, or x5 x4 x3 x2 x1 A0 B0 bar. This is expression for y. Similarly, we can write expression for z. In what way? Is whatever we have written over here, okay, we can write in a similar way. That is, what is that exactly is A5 bar B5, or x5 A4 bar B4, x5 x4 A3 bar B3. Now A3 is 0, A3 is 0, B3 is 1. In that case, it is A less than B. Then x5 x4 x3 A2 bar B2, x5 x4 x3 x2 A1 bar B1, x5 x4 x3 x2 x2 x1 A0 bar B0. This is the condition for A less than B, which I have written directly from the previous analysis. Okay. So this is what exactly the circuit. What I need to do now? I need to implement the circuit. So look at the expressions for x, look at the expression for y, look at the expression for z. So it is and or term. So it is anding, then oring, and or. So and or terms. Simply by using AND gates and OR gates, by using AND and OR gates, we can what we can do is, by using AND gates and OR gates, we can, from the above expressions, we can implement a 6-bit comparator circuit, which is simple and easy to implement.